Okay, so like I said, we're going to start quadrilaterals. We're going to focus on the parallelogram. Now, the biggest thing about this chapter is knowing all the rules that go with shapes. Okay, so there's a lot of rules, a lot of properties that your parallelogram holds. You got to know them really well because there's other shapes that are also considered a parallelogram that have properties unique to them. So you got to be able to keep it straight. That's the hardest part of this whole chapter. Okay. All right. So, by definition, a parallelogram is a quadrilateral with both pairs of opposite sides parallel. Okay? And I've got it marked here. AD is parallel to BC, and AB is parallel to BC. Okay? That's what makes a parallelogram a parallelogram. The symbol that we use for a parallelogram is this little mini parallelogram in front of the vertices. So if I were to name this, I would say parallelogram ABCD, and this is how I would write it. Okay. Make sure that when you list the vertices that you go in clockwise or counterclockwise order. Okay, so like ABCD or DCBA. Okay. All right. Now, some other properties of the parallelogram. Okay. Opposite sides of the parallelogram are congruent. So the opposite sides are parallel. They're also congruent to each other. So AD is congruent to BC, and AE is congruent to BC. So opposite sides are parallel, and opposite sides are congruent. Opposite angles are also congruent to each other. So angle A is congruent to angle C, and angle B and angle D are congruent to each other. So opposite sides are parallel, opposite sides are congruent, opposite angles are congruent. Consecutive angles in the parallelogram are supplementary. Okay? You notice that in a parallelogram, you have parallel lines cut by a transversal, right? So these consecutive angles are supplementary, and that's true all the way around. Okay? So you could say that the measure of angle A plus the measure of angle B equals 180. Measure of angle B plus the measure of angle C equals 180. We could go all the way around. Measure of angle C plus the measure of angle D equals 180. And then the measure of angle D plus the measure of angle A equals 180. Okay, so all the way around, the consecutive angles are supplementary. All right, here's another property. If a parallelogram has one right angle, it has four right angles. And it makes sense because if this right here is a right angle, your opposite angles are congruent, right? Your consecutive angles are supplementary. So if this is 90, this 90, this is 90, and then again your opposite angles are congruent. So if you have a parallelogram and you have one right angle, then you have four right angles. Okay? Alright, so let's work a couple of problems with those properties. It says that LMNP is a parallelogram, and I want to find PLN. PLN, this angle right here. Okay? What would I do to figure out PLN? What's it equal to, or what kind of relationship does it have? It's equal to MNP, right? Okay? And MNP is 108. So PLN is 108. Okay? How about LMN? This angle right here. LMN. Does it have a relationship with anything? We don't know what the opposite angle is, so we can't use that, but what else did we learn? The consecutive angles are supplementary, right? So if this is 108, this is going to be 180 minus that. So 180 minus 108, that's going to make it 72 degrees, right? Okay, and they also want us to find the value of D. One side is 2D minus 6. Does it have a relation with anything? Relationship with anything? It's equal to its opposite side, isn't it? Okay, so I can set 2D minus 6 equals 46 and solve. So I end up with 2D equals 52. Divide both sides by 2. And D is 26. Alright, any questions? Okay. Well, we've got some more properties for you. Now I'm going to talk about the properties of the diagonals of the parallelogram. Remember yesterday we talked about what a diagonal was. It was a segment that connected the two non-consecutive vertices of a polygon. Okay, we've got two diagonals here, AC and DB. And this first theorem tells us that the diagonals of the parallelogram bisect each other. Okay, what's that mean? They cut each other in half, right? So that where they intersect each other at, they do that. The midpoint. So E is the midpoint of both of them, yes? And so these two are congruent and these two are congruent. Now we don't know necessarily that they're all four congruent to each other because we don't know that DB and AC are equal. Okay, they're not as a parallelogram, just in general, okay? Special types of parallelograms, yes. Okay, we'll learn more about that later. But these two parts are equal and these two parts are equal, and they share the exact same midpoint. Okay? Alright. Each diagonal of a parallelogram separates the parallelogram into two congruent triangles. So if I just drew one diagonal, like I did here, DB, then it breaks these two triangles into two congruent triangles. And so I can say the triangle DAB is congruent to triangle DAB, I would have to say triangle BCD. Okay? Obviously, A and C correspond with each other, right? You've got parallel lines here cut by the transversal. So my alternate interior angles are congruent. So these two are congruent, and then same here, these two are congruent. So the reason I wrote DAB and then I wrote BCD because this D corresponds with that B. Okay? Alright, so let's work a couple of problems here. If QRST is a parallelogram, find the value of the indicated variable. Okay, what would I do to find X? What would I do to find X? Does this expression here have a relationship with anything? We're to its opposite side, right? So I'm going to set 5x equal to 27. Divide both sides by 5. And x ends up being 5.4. Okay, what about the y's? Do they have a relationship? They're congruent. The diagonals intersect at the midpoints, right? So those two are equal to each other. So I'm going to do 2y minus 4 equals y plus 4. So that gives me y equals 8. And what about z? We got that 3z over there. Is it equal to anything? Supplementary to anything? It's equal to 33. Remember, we've got parallel lines. We've got parallel lines cut by the transversal. Okay? So remember, your alternate interior angles are congruent to each other. Okay? So I'm going to do 3z equals 33. And so z is 11. Okay, any questions on that? Not hard, but lots of little rules that you really, really, really need to make sure that you remember. Okay, what are the coordinates of the intersection of the diagonals of parallelogram ABCD with the following vertices? Okay, so I'm going to graph this to start out with. Okay, X is located at 2, 5. is located at 6, 6. B is located at 4, 0. D is located at 0, negative 1. A, B, C, D. Okay, so I graphed it. Now it says, what are the coordinates of the intersections of the diagonals of the parallelogram? What did we learn about the diagonals of the parallelogram? Well, if you do one diagonal, it makes two congruent triangles. What if you do both diagonals? They intersect at each other's midpoint, right? They bisect each other. So what am I going to do to find out the coordinates? What? You could draw both diagonals, but if you're like me, I don't draw very well. You could. If I drew this one, and if I drew this one, I'm going to get an idea, but it may not be perfect. Okay? If you're going to get your ruler out and make it, it's going to be perfect. Well, what can I do? They intersect at their midpoints. We've done this like 50,000 times. Well, maybe not that many. Huh? Well, the distance formula tells me how long the diagonal is. I want to know where that location is. I want to know what this is. And this is the midpoint of both of those segments. It's right here, somewhere in here is the midpoint of both of those segments. Did we learn anything about midpoints? We have a distance formula. Do we have a midpoint formula? We do, don't we? Right? Isn't it the average of the midpoints? So when you average something, you add in, divide by 2, right? Because there's two things, right? Okay. So your midpoint formula is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Okay? Now, do I need to find the midpoint of both of them, or can I just find the midpoint of one of them? Just one, right? Because they share the same point, don't they? Alright, so let's find the midpoint of AC. So if I found the midpoint of AC, I'm going to add my x's together and divide by 2, and then I'm going to add my y's together and divide by 2. 2 plus 4 is 6, divided by 2 is 3. 5 plus 0 is 5, divided by 2 is 2.5. Okay? So my midpoint is 3, 2.5. This is the intersection of the diagonals. You might have to use the slope formula. Okay? They might ask you to determine if the opposite sides are parallel. How do you know if two lines are parallel? What do you look at? Their slopes. Their slopes have to be the same. They have to be congruent, right? Okay? You might have to determine if the opposite sides are congruent. If the opposite sides are congruent, what do you look at? Distance, right? So don't forget about the distance formula, the midpoint formula, and the slope formula. Okay? All of those are going to come into play. Alright, last one. Write a two-column proof. Now, first thing that it tells us is that ABDG is a parallelogram. So that means all those properties that we learned apply to that little shape right there. It also tells me that AF and CF are congruent to each other. Okay? I want to prove that angle BDG is congruent to angle C. So I somehow have to make a connection with those two angles. So let's look at my red parallelogram to begin with. Okay? I've got a parallelogram. What did we learn about the angles of the parallelogram? We learned two different things. Which ones are congruent? The opposite ones, right? So these two angles right here are congruent to each other, right? Okay? It tells me that AF and CF are congruent, which means this is an isosceles triangle, yes? And so if these two sides are congruent, what can I get from that? AF is congruent to C, right? Isosceles triangle here. So if this angle BDG is congruent to A, and A is congruent to C, can I make a connection right here? By using what? The transfer problem. Yes. Okay. So we have parallelogram ABDG and AF is congruent to CF. Now we took this part of the given and we said that angle BDG is congruent to angle A. Okay? And that's by that theorem, opposite angles of a parallelogram are congruent. Then we said angle A is congruent to angle C. And what was my reason for that? Isosceles triangle theorem. So if BDG is congruent to A and A is congruent to C, then angle BDG is congruent to angle C. And what's my reason? Transfer. Okay. Well, that wasn't that hard, right? Not that hard. Okay, so let's talk about the things we learned about the parallelogram. Okay, what did we learn? What makes a parallelogram a parallelogram? Okay, you got opposite sides parallel. They're also congruent, right? Okay, so opposite sides are parallel. Opposite sides are congruent. What else did we learn? Huh? What'd you say? Opposite angles are congruent. What'd you say? Consecutive angles are supplementary. Good. Okay. What else did we learn? What did we learn about the diagonals? They intersect each other's midpoint. They bisect each other, right? Okay. What if you have one right angle in a parallelogram? Then they're all right. Okay, good. I think that's everything. Let's double check here. Last hour. Opposite sides, opposite angles. Then we talked about diagonals bisect each other, so that you're. Oh, did we talk about this one? If you draw one diagonal, makes two congruent triangles. Okay, we got that. All right. Any questions? Okay, your assignment is on page 407.